Hi, I'm George, and in episode 22 of the Horizon series, we're going to have a look at the tiltable platform that the whole rocket's going to sit on that forms a part of the Horizon launcher. We'll also have a look at some of the design decisions, so let's jump straight into it. This is a more up-to-date model of what we're building. This is the bit we're going to look at today, including the launch tubes and mounts. On this launcher, the booster is held down by the central release mechanism, so we don't need individual release mechanisms for each nozzle. At these pressures and forces, it would have been far too difficult to synchronize them all for simultaneous release. The central release simplifies the design somewhat. The details of the base that this platform's mounted on we'll leave for a separate video. Let's start off with the launch tube mounts. Normally you could just attach a launch tube mount directly to a base plate like this. Here's the launch tube and here's the nozzle seat. And the air supply comes in from the bottom. But in our case we have a couple of extra requirements because this is a cluster launcher. All the nozzle seats have to be free to move in relation to each other for two reasons. Number one, because of the high pressures used, we're working with very tight tolerances, and so trying to get the booster to match the nozzle spacing on the launcher exactly would be very difficult. If the nozzle seats are free to move, they can align themselves exactly with the nozzles without wedging. This also means that if we make a second booster that will have slightly different nozzle spacing, the launcher will be able to easily align itself with the new booster. The seats don't need to move very much, just a few millimeters. The other reason they have to be able to move is because as the rocket's pressurized, it will expand and push the nozzles slightly apart. If we don't take this into account, we may end up wedging the nozzles against the launcher. These are the same reasons for the design of our previous cluster launcher. The nozzle seats were free to move in these tracks. So this is fine if the launcher stays vertical, but we have to be able to tilt it so we can get the rocket onto the launcher. If we had a freely moving launch tube mount like this and we tilted it, it would put a lot of stress on this one single point because of the weight of the launch tube, and especially when you're trying to manhandle the rocket onto the pad. To solve this, we extend the mount like this and add a second base plate here. Now if we tilt the entire platform, the mount is supported in these two places, spreading the load and stopping the launch tube from sagging too much. So let's make these mounts out of these brass hex bars. The main part of the mount is made from two pieces, mostly for ease of construction on a small lathe. The first piece is made from 34mm brass hex bar. This provides the mounting point for the nozzle seat and launch tube. We then cut a thread on the bottom to screw into the second part. And then we also cut a thread in the top that will mount the nozzle seat. Each of these threads will be sealed with an O-ring. It's time to make the lower half of the mount. This is achieved in a similar manner to the upper part. I guess it's a few millimeters out, so let's fix it. Dad then spent a couple of days machining all the parts for all of the launch tubes, including the nuts that go on the bottom to secure the entire mounts, preventing them from falling out. He only ruined two ties. This is what all the parts look like as individual pieces. And here they are fully assembled. The nylon washers allowed the whole mount to easily slide on the base plate. Next up are the actual nozzle seats. These are machined to exact tolerances to fit the nozzle. This seat has a couple of O-ring grooves to support a pair of O-rings. While only one O-ring is needed to seal the nozzle, we decided to add a second O-ring because these O-rings are exposed to the environment at the launch site and so could get dirt on them and not seal so well. The last thing we want to do is abort a launch because we have a dirty O-ring. We first clean the copper tube as well as the nozzle seat. These then get tinned and we're using some flux to help the solder flow better over the surface. Once they are tinned, we just put them together and heat them until they slide together. This was repeated for all 3 launch tubes. When we are finished, these will be polished up again. The launch tubes with their nozzle seats are removable from the mounts for easier transportation, or if we manage to bend a launch tube during launch. That way it's easier to replace. The tiltable platform is made from a 100 by 25mm aluminium box section. This part needs to be really sturdy as there are different forces acting on it at different times during launch. While the rocket is on the pad unpressurized, the frame just has to support the weight of the rocket, which will be around 20 kilos, including water. Once the rocket is fully pressurized, the central release head will be pulling on the central tube with a force of around 700 kilos or 6,800 newtons. And at the same time will be pushing down on the launch tubes with equal force in the other direction. The force on the support legs is still around the 20 kilogram mark. As the rocket is released, the force on the central tube disappears and that full force is briefly transferred through the frame via the pivot bolts into the base and into the ground. This is why the entire frame needs to be strong so it won't collapse during pressurization and launch. So let's have a look at how the platform's frame's made. First, we cut up the aluminium box section. This is so much easier with the circular saw. The frame pieces are joined together with angle brackets. It would have been stronger if we welded the frame together, but we don't have the equipment, and this also allows us to take it apart if we need to modify anything in the future. Each of the angle brackets is then attached to the frame sections with M5 screws. For the frame's end pieces, we drill a large hole in the middle that will be the pivot point for the entire platform. We then machine up a couple of brass bushings that will line these holes. The pivot bolts that will go through these will need to support the entire load during launch. They fit snugly into the end frame. Then we assemble the whole frame to make sure it's all aligned. The top and bottom base plates are made from 6mm aluminium. We mark out the locations of all the holes and then proceed to drill them out. The holes for the launch tube mounts are made to a close fit. Once we make the booster, these holes will be enlarged to let the mounts move around. Here we're doing a test fit of the launch tube mounts. Then it was time to mount the base plates onto the frame, making sure they were centered and aligned with the top and bottom. The pivots are made from M12 bolts. We had to sand down the thread a little to make them fit through the bushings, as the thread was a little wider than the shank. Here is the set of bolts that hold the top and bottom plates together with the frame. And in the middle are the 2 pivot bolts. Here's a time lapse of putting the whole frame together. This is how the high pressure hoses will be attached to the launch tube mounts. We push the high pressure seal in like this, and then just screw the hose on. When the entire platform was finished, we put it on the prototype wooden frame just to see what it would look like with the launch tubes, and so that we could check that the height was correct. Here we're putting in the central release head as well as the launch tubes. There are still a few small tidy up things we need to do to the platform, but otherwise it's ready. I think it has to go higher. Overall, we're pretty happy with how it turned out. Well, that's all for this week. In the next episode, we're going to have a look at the base that's going to be welded up out of steel to take all the forces that this thing's going to exert on it. Thanks for watching, and we'll see you next time. I know you're busy.